Hey, how's it going, everyone? I'm just back with another test for flat Earth, ball Earth type thing. So I just want to propose this, in the very least, conceptually, a test that doesn't have that many, really any nonlinearities. It does have issues with, just finding a day that is fairly calm, like in the atmosphere, to be able to be done, but I call it the level drone ride. So the way it would work, this would be the setup. You have a drone, and I believe most drones have a camera on them, and so we'll just point the camera downwards. And I just put another camera there just for visual. But so you have a drone that's shooting a camera downwards, and it has a ball suspended to it, connected by chain link, something that is taut, and the ball is heavy enough to ensure that the link is rigid and taut. And ideally, if the ball can be thermochromic, which just means that when it's in a different temperature, it will change color. And so this is the setup. And then so the idea is that if we were to fly a drone along a perfectly flat, straight flight path, and have the camera take a picture on a flat surface, on a flat Earth, that ball will never come out of the water. Every time the camera takes a picture, it would just keep seeing, it would just be shooting water. And you can go as far as there's enough battery life in the drone, and it will just keep shooting water. So it would take this path, you'd move over again along that straight flight path, and then it would shoot water again, and so on. And so ultimately, as long as that flight path is honored as being straight and flat, then the ball will never come out of the water. And so that's the case, that if the Earth is flat, water doesn't curve. And then in the bendy water, the curvy water case, the ball would start underneath the water, and then as you move, it's going to start progressively getting closer and closer to the surface. And then at some point, once you move far enough, and this should be able to be predicted, by the curve calculator, just based on the dimensions of the Earth, you could actually predict exactly the distance it would take for this drone to move to be able to start seeing the ball come out of the water. And ideally, it can change color, but most importantly, the camera will take a picture of it. So it moves a certain number of feet or miles, and then eventually, the ball cannot stay submerged because the water is curving away from the drone. So to me, this is, linear and visual and very, very repeatable. There's issues, obviously, if it's windy, and just getting stability. But the nice thing about this is that, you can sit the camera there for a moment, let the chain sort of find its, its rest, and then take a picture at that point. But there's obviously the main issue with this is again, like really every test like this, is ensuring that you're following a perfectly flat, straight line, to make it a fair test. So you're not, infusing any kind of curve or bias into the test. So that's obviously a challenge, but I don't know, with like drone technology, or if this is scaled up to like a helicopter, this seems doable, that there is a way that this can be done in a way that both sides would, acknowledge is fair in terms of the direction, and, that it is actually a straight, flat flight path. But, I just put that out there. Again, if people get an interest, or somebody has a drone that, we can suspend something off of it. And it doesn't really have to be, it shouldn't really be that big. Like the length of the chain and all that, you don't really need it to be that long or heavy. It just, again, needs to stay submerged underwater and have a little bit of wiggle room where it's beneath the water appreciably, just to make sure that, to account for the fact that the conditions might not be ideal. And so it definitely needs to start very, very much submerged in water. And then the shape of the Earth needs to be the only thing that exposes it to the air. So anyway, I just put that out there, but hope everyone's doing well. Bye.